Alright, what makes a good model is the definition of all the detail. And this is quite small. And here, for instance, I've got an ordinary household pin. And that's the size of a rivet for this particular model. And that's very small. And when I think about the other things I'd have to make for this model, things like the clack valve which goes on the side of the boiler, it's actually a tap, it's got a handle on it. And I don't think I could make one small enough that would look realistic to fit on this particular model. So, having spent all that time making all this, you guessed it, I'm not going to make that one. I've changed my mind. So, the alternative then is to make a bigger model. And that means the side frames will have to be in two parts because of the amount of space I've got on the milling machine. In particular, the X travel. Now, if I go out to a quarter, that's not too bad. But it would be better if it were bigger still, so I think I'll go it up to a third. Now a third is quite a reasonable size. It will end up about 600 millimetres, that's a couple of feet long, which is quite a big model, so I should be able to get some quite decent detail into it. It would be possible to make it an actual working model in this size. But I don't have a track, and the spacing on the wheels, I've no idea what it's going to be, but I'm sure it won't match anybody's track. It's just going to be a working model. But there's no reason why it couldn't work in a stationary position. I could have it on a rolling road or something like that. Even down to the slide valve. Thinking about the actual slide valve on the cylinder, on the chest. On the one I made, I think it was about 6 millimetres. It may have been a quarter of an inch if I was working in imperial on that. And 1/3 of that is 2 millimetres, so it's quite feasible that I could make the inlet port 2 millimetres wide and it would actually work. So it's a consideration I shall think about when I carry on making the model. And I've made a start. Here are the two pieces. Which fit together like so. Well, it's set up for soldering. I can just about feel where the line is, and to make sure it's exactly flat I've actually had to use pieces of paper to get the level exactly right. I've applied flux along here, and because it's water-based, I've warmed up the plates until the water is evaporated. Otherwise it'll bubble up, and these little bits of silver solder that I've cut off, they will get moved, and hopefully they'll stay pretty well where they are. And I'm going to heat from underneath, and that should draw the metal through. still bubbling a bit, but they seem to be more or less staying where they are. The only bit that bothers me is this corner where it's a little bit smaller and therefore could get too hot. Well, it's pretty hot, but it's not going to melt it, I don't think. Let's try a bit of oxypropane. The surrounding brass is pretty hot now. Right, that's it. And hopefully it'll have gone right through. view after it's been cut out, and it shows the tabs that hold it in place, stop it jamming the cutter. So I got the depth pretty well right. Might have been slightly too deep because the tabs are a bit on the small side, but it didn't move, so it's done a good job. Okay, well that's cleaned up quite well. The join hardly shows, which is more than can be said for this first one we did. It was all because of this angle, which seemed like a good idea at the beginning, but when I came to heat it up, of course, it's impossible to get all this metal to the same temperature so that it expanded the same amount. So it didn't fit very well. There were a few hollows, and so I filled those with ordinary car body filler. It won't show after it's all been painted. The reason I haven't drilled any holes and only marked them is because I'm not sure yet which holes are going to be what size, because it's going to be something like 6, 7 and 8 BA. So the next job is to make the 2 buffer beams and then to fit it all together. This shows the difference between the 2 sizes. The smaller one was soldered together, but this one I've used the same as on the original, which was to use pieces of brass angle and bolt through. Unfortunately, one of the things that happens when you scale things down is that the bolts here are going to foul one another. So that's something I'll have to work on. Never mind. It's only held together with a minimum of bolts and screws and things because the next job was going to be the axle boxes, and these holes here I'm going to rivet in again the same brass angle on the back as a guide for the axle box to slide on, and I'm going to use rivets. There's another device on the top here for holding the springing. Now fortunately, I've got some of the old Imperial rivets, if I can just hold some. They're pretty small because they come in 2 sizes. If I can show the heads. The smaller one is a 16th, and the next one is the next size up, which is enormous in comparison, but it's actually a 3/32. It just doesn't sound that much bigger, but it is quite a bit. Now I could buy some modern rivets. They do a 2mm one, which would be in between the 2. But I don't think I'm going to bother, since when it's all riveted together and then painted black, and then you've got the overhang of the running boards, you're just not going to see the difference between the head sizes, so long as it does the job. The front buffer beam has got another piece on the front here which extends, and I believe it was a well tank. Anyway, the hole is for the single coupling, That's a massive thing and it's sprung loaded. But how much of that I'll put together, I don't know. Anyway, that's it. Thanks for watching.